Hi, today I'm going to be showing you the Anatek Corporation blue ring tester. I purchased the assembly kit. I'm going to be assembling it and doing a short video review. The blue ring tester by Anatek Corporation is designed for testing the primary windings of most power supply transformers, or you can test secondary windings, pretty much anything with a high inductance. So like secondary windings on LCD inverter transformers. I believe you can test some just straight old inductors with it. Anything where there's a decent amount of inductance, where a continuity test won't really show you whether or not there's a short, because you can have a short quickly in the windings or long in the windings, and you'll still show low continuity, or I'm sorry, high continuity, you'll show low resistance. But what this does is it sends out a pulsed oscillation, almost like ringing a bell, and if you imagine you have a long coil of wire, that oscillation will show ringing a good amount of distance down there will be a long time until it falls off, whereas if you have an early short, it'll fall off right away. Kind of like if you cracked a bell. You'll get a quick dull sound versus a long, smooth, clean ringing sound. So that's kind of a simple analogy as for this. But this is the kit you can get here, the blue ring tester by Anatek Corp. And I purchased it on Amazon.com. You can also get it straight off Anatek's website right here. You just go to AnatekCorp.com. And it's about $42 for the parts kit and $10 shipping. If you aren't comfortable assembling, or you don't have the tools required to assemble the kit, you can also purchase it fully pre-assembled, and that runs you about $59. So you do save about $17 or so by buying the unassembled kit and assembling it yourself. And I thought, since I do have all the tools necessary, it'd be a lot of fun to go through it part by part, get a chance to see all the parts involved, get a chance to assemble it myself, and then reap the rewards of properly assembling it, hopefully, fingers crossed, by testing some transformers with it in the end. And the reason why I needed to get this is because I've started doing some power supply repair. And when you do power supply repair, when you've got a dead power supply, the board can look perfectly fine, but you can have issues, things like shorted diodes, bad bridge rectifiers, bad filter capacitors. And I've got an ESR meter, I've got a good multimeter, I've got getting an insulation tester for testing those big filter caps. But the one thing I was really missing was a ring tester. Now, some people will say you don't really need these. Some professionals might have better equipment that can do something similar to this, or there might be more professional versions of these. But this, just like the blue ESR meter, is a simple tool that you can get and assemble for really quick bench repair work and testing, and it's very effective. The cost benefit is very high, I would say. Not a lot of investment for a pretty good return in usability. So again, it'll be just a way of being able to quickly eliminate the transformer as potentially being a problem when I'm testing components in a power supply. Now, you do have to download the manual from the website, so I've got Anatek Corp open here. I'll be downloading the manual off of the website shortly, but first I'm going to bring the camera in close and we're going to take a look at all the components in here and just get an idea of what all is in it, and then we'll go through and we'll start assembly. Okay, now that we've got a closer view here, I'm going to open the box, and I already took a peek in here earlier, and I noticed right away that there were no ESD bags used in packaging all the components, and there are some transistors in here, as well as some diodes. So first thing I want to do before I go poking around in here is hook up to my ESD system here. So I'm going to put on my little ESD wristband here and plug into my mat, which is grounded through my house wiring, and that way when I open this, any triboelectric static electricity that I generate will hopefully be dissipated through the bag and the surface and my ESD system here. So let's see what you get. Comes with a little brochure. Anatek Corporation, Solutions for Electronic Hardware Repair Centers. Family-owned business since 1991, and they just show you some of the different components that they sell. The famous blue ESR low ohms meter. This is the blue ESR meter, and of course the blue ring tester, and then a couple other components. Actually, the Atlas, I believe these are from the UK. I actually own this ESR meter. Instead of buying the blue ESR meter and assembling it, I actually bought this slightly nicer one because it can discharge some capacitors automatically, and it just has a really nice interface. I really liked it. But for the ring tester, the blue one seems to be of good quality. And so some of the other components they offer, I have purchased from them before, so they're definitely legitimate. And we also have here my invoice. Just says $42 plus $10 shipping. So now we get to the good stuff. miscellaneous parts. And in here we've got a little piece here, a zip tie, looks like some alligator clips. And let's see, I'll put these back in the bag after I take them out, but we've got some shields for the alligator clips, some copper wire, looks like it's probably coated, and some screws, and looks like a little trim pot or a button. Oh, yep, it's a push button. And so a couple little miscellaneous hardware parts. And I'm going to keep everything together initially here, just because I don't want to get all my sections messed up. But once we get in the manual, we'll actually get the stuff out. And we've got capacitors. And it looks like we've got one electrolytic and a bunch of those little chiclet looking types. And we've got semiconductors. And this is where I was talking about. You can see these are just in here loose. You theoretically could probably shock these if you generated enough static or had a charge on you. Since I'm grounded, I should be safe, but at the same time, always good to observe ESD precautions. So here we've got 3 little transistors. These are 2N3904s, which I think are either PNP or NPN, I don't know offhand. I think I've got some actually. And these, I'm not sure what these are. Texas Instruments and STI. We've got an HCF4015BE and a, this could be the serial number or the model number, 05AGS3M. I guess I'll find out what these are in a bit here. And we've got some diodes, which of course are also semiconductors. You got PN junctions. We've got a piece of what almost looks like broken plastic. I'm not exactly sure what this is for. Hopefully for something, and hopefully not broken. And we've got what looks like some Zener diodes and some LEDs. These LEDs, most likely, of course, for the meter part itself, where it's going to be the visual indicator display. Put these back in here. I really hope this does go to something. Very strange looking. Okay, and then we've got what looks like some resistors, some standard 5% tolerance resistors. I'm sure everyone's familiar with these. And there's what looks like a little note in here. Let's see what that says. So yeah, a couple resistors. Late design improvement. Well, that's always nice. Let's see here. Oops. One of them fell out. I'll have to get out my multimeter or my little guide on the colors later. Let's see. R7 is changed from 2.2 kilo ohm, as shown on PCB silkscreen, to 510 ohms. This gives the tester improved sensitivity when used on low impedance devices such as switch mode power supply transformers and the horizontal winding of deflection yokes. Very cool. So they've actually, this is one of the advantages to getting something that is not pre-assembled, not a commercial Chinese product. They've actually improved the design here, and this was something I commented on a moment ago, which was that you usually can't use this tester on low impedance devices like the secondary side, or even, yeah, some switch mode power supplies, so, or power transformers. So this is great. There's a small improvement, and hopefully I can do some testing with that later to see if maybe I can get a reading on a secondary side. Now, I just hope that it doesn't decrease sensitivity or impact sensitivity on its original purpose, which is on the primary side, because that is why I purchased it. Looks like we got the PCB pretty nicely packaged in here. Yep, there's the PCB. It's kind of sexy there. See if I can get a nice close shot of it. Yeah, this thing macro focuses pretty well for a webcam. So there's the PCB, and I believe it's a single layer, dual-sided. And let's throw that back in there. And Anatek Corp. We emailed the assembly manual and the user manual to you. If If you've not received them, you can download them there. I don't think I did, so I will be downloading them. Here's the sticker. This goes on the device itself, and it'll show you where to look for the LEDs over here. Here's the enclosure itself, with more QR codes on here, scan to view all our products, and the ring tester manual. That's kind of neat, stickers on there. So here's the actual case itself. Let's open this up. All right, and inside the case, we've got what looks like some battery clips and the battery terminal, standard 9-volt little terminal clips here. There you go. And some screws here. And you can see they just screw into the plastic, so there aren't any metal screw mounts or anything. This is probably just injection molded. Not a big deal. We don't need anything terribly fancy. And it looks like the back has a battery cover door. There we go. And inside here, this must be who manufactured the case itself. And thanks, Bob. Bob 201. Looks like he did a good job. Looks in order. And so that's almost everything. Put the case back there. And the last two components in here are the wires for the testing leads. Right there. So that is everything. Next step then will be to download the manual, and then we'll start going piece by piece. And I'll see if I can switch my light over from a fluorescent to an incandescent, because we're getting a bit of flickering on the video. But next let's get the manual, and then we'll hopefully maybe do a little time lapse, and I will start the assembly. Just to quickly show you the importance of testing and thoroughly going through all the components that are included with assembly kits. Sometimes you might run into some discrepancies. I was just verifying on the manual the list of, I almost said ingredients, but the list of parts that should be included with it, and it's easy to get caught up because on the parts list in the manual they list everything by resistor colors. As you probably know, little resistors have color bands on them. See if I can get this into focus. Basically they have little colored bands, a bit hard to see, but there's little tiny bands on there, and the order that they're in and the color that they are, there's a standardized system you can use to determine the value. Different, obviously you can use just a multimeter as well, but if you don't have a multimeter handy, or you're trying to quickly sort through them, if you can memorize these color combinations here in the bands, then you can easily determine the value just by the bands. So on the manual they list the numbers of resistors you should have and the colors, and I'm going through and I'm noticing right away that some colors are off, and specifically that this one here, there's supposed to be one 270 ohm red, blue, brown resistor. Well, this one you won't be able to see it on the video, but it's very clearly violet, and in fact violet is 7, so if you were to go red, which is 2, violet, which is 7, and then we have brown, which is 10. You do 47 times 10, that gives you 27 times 10, that gives you 270. So this is the correct value, it is the correct resistor, but the color that they actually list on the manual is wrong. So if you were to just simply go based on color alone, you would think that they sent you the wrong parts, but they didn't. Same thing I encountered with these two resistors as well. These ones are yellow, violet, yellow, but on the list on the manual it says, let's see here, 470 kilo ohm. It doesn't even actually list colors, it just says 470 kilo ohm. So I know based on the colors we have, let's see, yellow, which is 4, violet, which is 7, so 47, and then yellow, which is 10K, so 47 times 10K, 470K. So we know that this is a 470K. I also verified it with my multimeter's resistance measurement. But just to show you to be extra careful when you're doing any sort of assembly, before you go soldering in parts, thoroughly go through everything, double check your values, double check, because these are 5% tolerance resistors, sometimes they could be off, and make sure that you've got the correct components, because you don't want to find yourself 90% done soldering and find out you have one wrong component, or find that you need to contact the manufacturer and send parts back, or anything like that. So just a reminder to be careful with your inventory and to verify everything. Okay, so I did figure out what this little piece of plastic is for. You are supposed to get it. It's actually a small shim for aligning the LEDs. So you can see I've gotten all the components up to the ICs installed now. I started with the smallest components, which they recommend, which is all the resistors, then the capacitors, then the transistors and ICs. And now we're moving on to the last step, which is the LEDs. So for that, what you do is you tack down one on each end with this little shim, then you slide the shim out, and then you're done. So basically it's to give you a nice even level to have your LEDs on. So I'm going to place them in, and that'll be the next step. Okay, so now that I have my even LEDs, roughly even, as far as height is concerned, then you take the other side and you bend them over. Same time, I'm also verifying that these are all of the short leads so that I don't have the polarity reversed. You don't want to accidentally reverse bias your LEDs. Now I just bend over on this side. Okay, there. Now my LEDs are in. My leads are bent out. Now I will carefully pull out the shim. There we go. My bad. This is what happens when you rush things occasionally. I saw that and I thought, that's a big hole. I should fill that with solder, but it's actually, you're supposed to fit the leads through it. And then you're supposed to solder them into this spot here. So, whoops. Let me just pull the solder out of that. I looked at it and I'm like, wait a minute, that doesn't connect to anything in the circuit. So I'm going to have to suck the solder out here. Small mistake. There we go. Okay. That is for the zip tie. That's what that's for. Whoops. Okay, let's try that again. This time I will flux the correct lead areas. I will not fill them with solder because they're actually of a good size. There we go. Okay. Now we've got a nice amount of solder on there. Now we take our zip tie. This gets threaded through the holes that I had previously filled with solder on accident. And I'm just going to tighten this a little bit. I don't know if I'm going to tighten it full yet, but we'll get it in there and get it started. Okay, and I will tighten that fully after I finish the switch, which is next. And I just need to tin this real quick. Since I'm not using rosin core solder, I'm using solid core. I have to flux everything. And I also have to keep my tip tinned all the time. Now, the advantage, in my opinion, with solid core solder is that you don't have to worry about mixing fluxes. You don't have to worry about matching the solder that's in your rosin core solder. You don't have to match the flux to whatever additional flux you might be using. I just have to worry about the flux I'm using. And in addition to that, then it's not good for your tip to always be eroding it with flux. Every time you tap solder to your tip, if it's got rosin core, you're refluxing it, and that will wear your tips down faster, technically. Now it'll also make it really easy to keep your tip tinned, but that's why then I have tip tinner. I have a little thing of tip tinner, so I use that once if my tip has any issues with tinning. But at the same time, with a good soldering iron tip, kept clean, you've got a sponge, you've got a steel wool brush to keep it clean. You shouldn't have to flux it all the time. Alright, so let me tin this. Okay, our switch is in. That lines up well right there. So now that we know our switch is going to fit good, I'm just going to go ahead and line this up. Pop it in the spot where it's going to go. Make sure everything fits okay. Okay, and now that I know that this all fits, I'm going to do my final tightening of this. Okay, that's on there nice and tight, and that's going to be a really good stress relief. There, now you can see that when I wiggle this, well, it's not going to be easy to see there, but let's get some focus. Come on. Come on. Here we go. Okay, when I wiggle this, it does not wiggle past the zip tie, which is good. That means it's acting as a stress relief. Just gonna clip that off, so we're good there. And we're almost done. Next I have to do the connectors. So I think this is almost the second to last part that I need to solder on here. I believe I need to solder the battery connector on. Okay, there's our cleaned and assembled board, ready to be installed into the enclosure. Not too bad. And if you're in a hurry, you don't have to do it as meticulously as I do. But I think you'll see that with a few extra steps taken to carefully flux everything, you can get and clean it, you can get a really, really, really beautiful job. All my solder joints are nice and shiny. I'm using leaded solder, of course. Buttons in there good. All right. Now we do the final assembly. And before we do the final assembly, we do have to complete the couple test leads here. So I've stripped about 1/4 inch off of each end. And then I'm going to place these little shields over each wire. And the instructions say not to tin the wires first, so I'm not going to tin them first, although I don't really think it should make a difference. Okay, I'm going to go ahead and put those there. Now I am going to flux them, even though it says not to tin them. I definitely want to flux it. Okay, so get some nice flux on the end of each wire. And then I'm going to flux this. These are the alligator clips. And this one as well. Flux it nicely. Okay. Now these end up getting sort of crimped over it. Put it up and then you crimp it into it. Actually, I'm going to flux a little further up here because it looks like it goes quite a ways. Okay, now we're nicely fluxed. I'm going to take some pliers and come on, focus, front focus, front focus. There we go. Okay, and now I'm going to basically crimp this, right, these little tabs right onto the insulation here. So I'm going to get it up onto there a bit and just going to crimp I'm going to start a little gently. So in case I have to undo it after I solder it, I can. Just going to kind of bend the wire down so it's a little bit flat. Pressing into that. Now I'm going to put a nice big glob of solder on there. Oh boy, okay. Didn't work so good. Ended up melting the rubber. So I don't like the way that they tell you how to do this. They tell you don't tin the wires. Don't tin them at all. I'm actually going to start over. I'm going to even these out. Because I've done input jacks and stuff before, and I've had no problems with them. And I'm glad I didn't crimp this entirely. So I'm going to actually pull this back a little bit. Like the rubber's coming right off. Okay, I'm taking the rubber off. Now I am going to tin it, because I think it'll work fine if I tin it. And the answer is yes, it can be soldered to. One section of it I was able to get hot enough, and sure enough, let's see if I can get a close-up of this. Ooh, that's still very, very, very hot. It had to heat it up considerably. My Metcal is able to dump a lot of heat into something when it needs it. It's a little bit hard to see this, but I don't want to touch to my hand too much because it's still very hot, but you can dump a lot of heat in. You need to be able to dump a lot of heat into something to be able to solder to a large metal plane like that. Plus it's heat sinking it slightly with this set of pliers. Okay, good. So it is possible. Let me do the same to this one, and then I will tin the wires, and then basically we will just melt the solder to the solder. Because once we've got a good metallurgic bond between solder and surface, then the heat transfer should be fast. At least a lot faster than it started out. So again, I'm going to get a nice, good amount, especially because while it's heating, it's going to take a while. So I might lose some of my flux while it initially heats up this thing. Okay, we're going to do this again. Start by just putting a little drop in here, and we're just going to wait. And I've got, okay, here we go, okay, and it's soldering to it. Dumping in some solder. Okay, excellent. There we go. Now I've got solder attached to there. I much prefer a soldered elevator clip if possible. It'll be a much better connection. Still very hot. Ooh, okay. Switch back to our first one. And now, unlike what they said, I am going to tin these. So let me get my wire strippers again. And here we are. Now the only other reason I could see maybe wanting something different is if you wanted some sort of quick connect type system. The fact that, for instance, these are alligator clips and you're supposed to be able to do in-circuit tests, alligator clips aren't the best, so I'll probably be clipping alligator clips onto like a test lead or something rather than using these directly. So I may later eventually unsolder these and put in some sort of quick connect system, maybe something that could work in tandem with my lead sets that I've already got from other multimeters, but we'll see. Okay, and now I'm going to tin my wire. That one sucked up a lot. There we go. Okay, now we've got a nice little bulk amount of solder on there. Now we're going to do the same thing we did before, except this time I'm basically only going to worry about getting the solder to melt to the solder. And I will not crimp it first because I don't want a lot of extra heat being dumped into the insulation. I don't want it melting. I won't be able to get a close-up of this because it's a bad angle, but I'll show you when it's done. Beautiful. Just what I was hoping for, and it did melt the insulation just a little bit, but not too bad. Still a little warm, certainly not as bad as it was initially. Plus having the higher temp tip can help a lot. You need to be able to dump heat fast before that heat has time to transfer to the surrounding components. That's something that I didn't understand at all about soldering when I first started learning how to solder, which was for something larger, if you sit there and try and heat it up with a smaller tip, you're going to end up damaging everything, because by the time the whole component comes to an equilibrium, everything else has heated up slowly. Whereas you want to quickly heat up one specific area. Okay, and it's in the solder pool, and letting it very carefully, keeping it still while it cools. We've got a nice shiny big blob of solder in there. That one didn't damage the insulation at all. So let me see if I can get a close-up of this. It's still a little hot, but oops. Okay, so right in there I've got that soldered, just underneath there, and then I'm going to take these little kind of wings on the end and fold them over, and that's going to give us our stress relief, or at least going to help avoid damaging that soldered connection. So I'm just going to bend each of these over. There's one. And I'm going to bend this guy over. There's two. Now we've got a soldered, very strong connection. Oop, there we go. Okay, and that'll be the last step before we get to actually put this in the box and then test with it. This piece seems to just be extra. I don't know why. It was in place of the other piece that goes in here. Okay, it's hard finding screws. Try finding it with a bunch of video equipment around you. Okay, let me get back up on my ESD setup here. Yeah, I don't like this. So it's sticking. The button is sticking because of the pressure on it. So that's going to be a problem if it's sticking on and off. It needs to be allowed freely to click. So what I think I'm going to do is let's take all these out. Let's see if there's any leeway whatsoever with the solder. If I can potentially solder it and adjust the angle just ever so slightly, it's going to be close. Or I may have to even widen the hole somewhat or something. But let's see if I can make this apparent. Okay. So the button here, if you can see, it's a little bit too close to this side where I'm moving my finger. It should be a little bit more centered. What's happening is this plastic is pushing on the button. Come on, focus. The plastic is pushing on the button, and therefore when it'll click down, it won't come back up. And since it's a momentary switch, why is it focusing behind me? Since it's a momentary switch, it needs to be able to click on and off, and not stay clicking, so, or not stay in one position. try and take some relief off it. So I'm just going to take a pair of scissors and just kind of carve out some extra space. This shouldn't affect the performance of it at all in any way. It may look physically a little bit less nice, but should hopefully alleviate this problem. And then keep this thing running smoothly as long as possible. Okay, so I've widened the hole a bit. So you got a fair amount of chunks off here. Okay. See if that improves it at all. Definitely doesn't look as good anymore. But there we go. Now we've got a nice clickable button. Now when I tighten this, I'm going to lightly tighten it. Actually, this one may already be stripping, because self-tapping screws are notorious for stripping the threads of what they're being screwed into. That already seems to be happening a little bit with these screws, so another small downside to this type of design. But we are in there pretty nice and solid now. And there we go. You can see the button now clicking freely. And ironically, pretty centered nicely now that I've got it cleared out there in the giant hole I made. Now we need to put in our battery contacts. Okay, I've tracked down a 9-volt battery. Now I'm just going to double check on these little clips here that they give you. They don't tell you how to put them in. It looks like they go halfway onto here like this in here, but I don't want to put them all in and find out I'm wrong on one side of them. So I'm going to carefully double check this here. And also for the first time I'm going to be powering it. It looks like the switch was on because the lights were coming up. So that's a good sign. Since the LEDs were turning on, we know that at least it must be somewhat working. Okay. Now we just need to make sure that we're not going to be putting these in here incorrectly. Okay, I think they do all just go in like this. See from this end if they even go in at all, actually. Looks like they may not even go in at all. Yeah, those don't even fit properly. So the best I can figure is these were maybe for if you were to use a battery that, I don't know, was soldered to it or clipped to it. I'm going to check the list of what it's supposed to come with. See if it even lists them. Okay, it does not even actually, so here's a tip also. For whatever reason, they sent me these clips for the case, like this, and they're not even needed. They're not even a part of the design. So I'm actually going to leave them out. And if I determine that there's something missing later, I'll put them back in, but it does not look like they go in there. So I'm going to take my connector off. I hate these types of 9-volt connectors. They seem like they're always going to break. There we go. Feels very, very solid. I'm going to turn it on. Get a change and get some lights up and going here. That's cool. Okay, we know all the LEDs are working, it looks like. So I'm going to leave this on for a second, and then I'm going to see it's blinking. And you can see the battery underneath it. That's kind of cool. Now I'm going to put on my sticker here. There we go. That looks good. Relatively centered, no bubbles. And that is the completed Anatek blue ring tester. Took me a lot longer when you're videotaping it, but that's it. Once it's fully assembled, a couple quirks I had worked out. Seems to feel very solid. We know all the components in it. I know how good the solder job is on all the components. So I know if something goes bad or shorts, I know I can double check my solder job and know that at least there isn't some bad joints that I need to worry about. I'm sure that the pre-assembled version probably is fine as well, but then you don't get to have the fun of assembling it. So the next step is actually to build this little inductor, test inductor. So I'm going to do that, we'll test it, and then we'll give our final thoughts. Okay, I finished winding the little inductor. It's a little test inductor. They give you just a small ferrite core along with some insulated wire. You just have to strip the ends then, strip off the insulation, which I've already done. So they give you this to test with. So now we're going to double check it and make sure that this works. It should be a high inductance, which should give us a good quality factor on here. So I'm going to hook up one lead, turn it on. Right now we're getting right now we're getting red on there. Let me see if I can get right on the end. And moment of truth. Booyah! There we go. So it's pulsing a signal on it and it's ringing quite nicely. So this is showing it as a good inductor. And I thought also, let's actually take a look at the signal that is being generated by the device. So I'm going to turn on my oscilloscope. And here's the signal that the machine is creating here on the inductor. Now it's not going to ring out very far because hopefully this is not an inductor. But you can see that it's generating a signal, a little pulse. Let's see if we can get more information on it. Okay. Oh, there we go. Okay. Getting about 4.8 hertz, 8.9 hertz, 4.8 hertz, 8.9 hertz seems to be pulsing back and forth, but there you go. There's the signal being generated by the device. It's about 3 millivolts. Or that's VTOP, so VPP about 184 millivolts total. So it's not a very strong signal, and in fact, it mentions that in the manual that the signal is not very strong. So there are certain instances where it will not work, but it's a trade-off because of the small portable size, form factor, and cost. Well, this completes my assembly and short review of the Anatek Blue Ring Tester. As you can see, it's not terribly difficult to assemble. It does take some time. The manual estimates about 1.5 to 2 hours for an experienced technician. For myself, it took a bit longer with a few breaks and with the video recording and whatnot, probably about 4 to 5 hours or so. I had a couple breaks. At the same time, you could make it a lot faster if you've got rosin core solder, you don't want to clean up any remnants of flux, you're not as meticulous as I am, etc. But if you like to do something right the first time, I don't see a problem with taking a couple extra hours to make sure it's done properly. And when you run into some strange little issues like the hole for the power button here. So issues I did run into, again, I ran into that this hole here for the power button wouldn't fit. I had to widen it with a knife or a scissors, make room there so that it was able to turn on and off easily. Now it does. Second issue is with the battery door. Even now it's still a little bit stiff, but I had to route quite a bit of that wire to get that to fit in there, and I actually had to kind of put it in there while it was taken apart. So you may even find that you actually have to take off these 4 screws and separate it to get your battery in and out. I don't think that's great design, but just a small flaw within the design there. And it sent me those extra clips which weren't even used. They didn't even hold the battery in place, and if I used them, I wouldn't even been able to fit my battery in there. Things I like though, the construction is pretty nice. The rubber on the test leads is nice. I don't feel like they're going to fail anytime soon. Sticker's nice. It's basic, it's simple, but it tells you exactly what you need to know. Lights here, good, high Q, questionable or medium Q, and bad or low Q, and none you have a short. And they give you their basic information here on the back, a couple QR codes, their brochure, the manual. That's a nice little feature. And I really like the rugged feel of it. My ESR meter is not an Atlas Blue tester, so I'm not familiar with this chassis, but it feels very solid once it's together. I mean, I can't twist it or anything. It's not like some cheap, Chinese type made product where you need to worry about that. Granted, I'm sure the case was made in China, but either way, it doesn't feel that cheap. It's nice and solid. I know now the quality of the connection I have going in here. I know that that's going to last. The alligator clips are okay. That's one thing I would like to see improved, though, would maybe be the option of some replaceable leads at the end, something that the Atlas products give you the option of. They have gold-plated little ends you can swap in and out with these little mini connectors. But I really like the rubberized sides and the secure feeling of it. Turns on and off very easily. And I think this will definitely be a very important part of my power supply repair bench when I'm fixing power supplies and testing transformers, especially also for LCD monitors and trying to test those inverters, the transformers for the inverters, for the screen backlights. That'll be important as well. So I think for about $42 plus $10 shipping, absolutely worth it. If you don't want to spend the time worrying about being meticulous and assembling it properly, definitely worth the extra $17 to buy it pre-assembled. If I didn't have any interest in knowing how it was put together or just getting some experience putting together a product like this, I would have easily spent the extra $17 to save myself the time. I think it may even come with a battery then. But otherwise, a great product, and definitely a big reason why a lot of bench repair people have these in their arsenal, because there's certain times where you may have tested every other component, you may think you have everything down, and your component still isn't working, you put it under a load and it fails, etc., and you're scratching your head, you can't figure it out. To have some simple device that can even be used in circuit, just quickly connect it, check it off your list. Know that it's probably not going to be the windings on the transformer. To be able to have that answered quickly, I think is very important. So again, great product, and I look forward to testing this and hopefully finding some shorted coils.